wave assignment people still haven't submitted. Let us discuss it. This is pending. We are on ray optics and this assignment is still hanging on. So let me discuss it. Whatever few points I'll write that you can copy later. First, just understand. And please, at least after today's class, share the assignment. Many of you haven't submitted assignments of alternating current and EMI also. Please share the assignment. Marva, your EM waves are left. Till AC, you have completed almost all the assignments.
Now I will submit. Like I have my exams going on, so I will submit after that.
Okay, no problem. See, as this says, a parallel plate capacitor, radius is given. Radius we've already done in the class. Second says area is given. Plate separation is given. Initially, it is charged to 80 microcoulomb. Okay, due to radioactive source nearby the medium. Just a second, class. Class, just tell me one thing. Take the note from the last class. Where did we exactly stop? From ray optics. We were doing total internal reflections numericals. What did we do exactly in the last class? Because Monday was an off, so we couldn't have our class. Please tell me. Somebody check the note and tell. Yes. Answer, what did we do in the last class on Wednesday? Yes, Aisha, say.
We did I was absent, but then I saw the recorded lecture. We did a mark a question.
No. After that, we had our class. Apparent depth.
Yeah,
From
apparent depth. Yeah.
after that one class we had, total internal reflection was done. Somebody else who was there, Jesleen, I think you were present. Jesleen was there. Jesleen, yes, what did we do in the last class? Do you people not just even open the notebooks? This is pathetic, at least. Okay, assignments, and why? What's the point of discussing the assignments if people are not referring to the notes? Please, basic class notes, open, go through it. And if you have any queries in the class notes, then let me know. We can have a discussion on that and then we can move on to the assignments. But at least basic class notes you should see. Jasleen was present, I remember. Marwa?
We did one
Yeah.
question. We did one question.
Which question, Jasleen? One question.
On
ठीक है,
glass
क्या
fiber.
कहते?
With
Okay, that
xerophone.
was completed. Was that
Yes, ma'am.
completed?
Yes, ma'am.
Okay. So basically applications of TIRB. Oh. See, class, at least revise through the class notes. In your most of the assignments, I keep on writing this in the sheets also, your test papers, that revise this from the class notes, revise this from the class notes. Anyways, and the test also, very few students attempt. Jesleen did that test. Very few students attempt the test also from this batch. Okay, so yes, I was just saying area is given, the separation is given, the charge is given. See, this is charge per unit time. Coulomb per second, which is saying no, it is basically not the current, the loss of charge. So that doesn't come under the category of current. Electric current nahi hai ye, theek hai? But this is actually the charge which is getting divided by time. So from here you can get the value of time also. It says what's the magnitude and direction of displacement current. See, displacement current related with what? Relate this with the potential one and the capacitance one. Capacitance will be given by epsilon naught A by D. So you will have the capacitance with you. Once the capacitance is there, now see what we'll do. This is given as dq over dt. Now we require the voltage. This is the initial charge. This is, it is charged up to initial charge. Due to radioactive source nearby, the medium between the plates get slightly conducting and plate loses charge initially at the rate of 1.5. Means this much amount of charge is going in 1 second. Okay. Magnitude and direction of displacement current. For displacement current, you basically require the voltage over here. Okay. If you get the voltage, you'll be easily able to calculate, right? Voltage is just missing. I made you write a formula also based on voltage and capacitance. Yes, we have written that formula. I is equal to C dV over dt. Okay, so dq over dt is given. Q is already mentioned, right? You have dq over dt given. Now, in order to calculate the displacement current, if you get this value, which is 1.5 into 10 to the power minus 8, this value is known to us. Now, look, voltage, for the calculation of voltage, you're going to apply Q is equal to CV's part, right? From here, now it's a one-liner, means in the sense in the final answer, you'll get it in one line, except the magnetic field between the plates. Magnetic field between the plates will not be given like that. For the magnetic fields between the plates, you will have to get the value of the flux, magnetic flux, then only you'll be able to calculate it, okay? So charge is equal to CV. Now from here, voltage is equal to charge divided by the capacity. Fine. So this says what is the magnetic field between the plates. See, for the calculation of magnetic field, what do we have? What all information do we have? You have the charge given. You have the current per unit time, which is technically the current, but this is not the current exactly flowing. What is the amount of charge which is getting changed with respect to time? Okay, that is present. Capacitance is present. So using capacitance, you will not be able to get anything. For the calculation of magnetic field between the plates, you will never be able to get it. So how will we approach? You will have to apply the whole concept of electric field. Okay. Electric field will be given by potential divided by the separation. Okay. This is the formula which we did from the gradient. Electric field has a gradient of potential, so E is equal to V by T. Now potential you will calculate from this, charge by capacitance, separation is already given, electric field will be calculated easily. Okay. Electric field is required. Once electric field is there, divided with the speed of light, you will get the displacement. You will get the value of the magnetic field. So electric field will have to be calculated first, and I hope you know we did this. B is equal to E. This I'll write it. The speed of light is equal to electric field divided by the magnetic field. So from here, the magnetic field will be calculated. Okay. Try this question. This is the basic question, same question. Charge is given, radius is there, this is given and all. We can leave this. Radius is given. Okay, let's see this. A parallel plate capacitor made of circular plates, each of radius 6 centimeter. This is the exact question, class. Like the first one. Okay. So refer to the first question for this third one. Radius is given, capacitance is given, angular frequency omega is given, 230. This is given. RMS value of current has to be calculated. RMS, you need the resistance. How will you get the resistance? For resistance, see, you require the linear frequency. Okay, angular frequency is given. You calculate the linear frequency using it, right? Angular frequency is given as 300 radian per second. Linear frequency can be calculated. Anyways, it's mentioned in the figure also that it is 50 hertz, and while calculation also it will come around 50 hertz only. So you can use this frequencies values value directly. Okay. So resistance is given as R. Resistance is not given in the question. Capacitance is given. So see, we'll consider this as if the single capacitor circuit is provided. My voice is lagging. Wait. Is it better now? Hmm? Is it better? My voice?
Yes, ma'am.
Okay. I was saying, see, in this I was saying that this is a capacitive circuit, no? Alternating current symbol is also mentioned. Okay, so capacitive circuit is there. For capacitive circuit, calculate XC. How C is given, omega is given. XC will be 1 by omega C. Calculate XC for I RMS. Use the value of voltage VRMS divided by this XC which is given. This divided by this. Okay, that is the first part. Second says, is the conduction current equal to... See, conduction current is always equal to displacement current. Why? The conduction current in the wires, this is your conduction current part. The current in these is always equal to the current in between them. Okay, current is equal to in between them. All right. So this is okay. One more part is there. Determine the amplitude of magnetic field at a point 3 centimeter from the axis between the plates. So see, for the magnetic field, see, this is the basic formula of magnetic field at the axis of a circle. Mu naught I r square by 2 r square plus x square to the power 3 by 2. R is this, is this. Okay, this is how you have to solve. Just copy down the basic points quickly. The next assignments I'll discuss later. We'll start with the class then. Please just copy it quickly. Okay, see class, coming to the applications of total internal reflection. First is the mirage formation. Now, what is mirage formation? This you must have heard of the term mirage. Now, if the voice breaks or something, please just tell me, okay? What happens is atmosphere has different layers. These are different layers of atmosphere. Layers of the atmosphere. Okay. Now what happens? The medium is different in each of them. 1, 2, 3, 4, like this. All of them are different. The way they are made. So what happens is they all these layers have different densities. Different refractive indices. All of these. So what happens when the ray of light strikes? Here you get the normal, and here the light ray deviates. Then again, this acts as one medium, this acts as the new medium. This becomes your angle of incidence here. This becomes angle of refraction over here. Okay? Now see what happens here. This is the normal. This diffracts further. This becomes a normal. Now what happens here is, this part I'll take as the total internal reflection one. See, let's take this as the critical angle only. So this grazes. Now see, when further you take, what happens? It will reflect. It will be totally internally reflected. So here you will get the image formation. Here is your object. Here only you are getting the image, where the image should have been formed somewhere else. Or in fact, no image should be formed. Normal atmosphere is there, normal air is there, then why can we have it? That is, and this is one of the categories of optic illusion. Okay, this is one of the categories of optic illusion. Optic illusion means something that is not present and we are able to see because our mind perceives it. So what happens in scorching heat or in deserts, you will find mirage formation. Or many a times in deserts, what happened? I think you must have heard of this term in literature also, as a metaphor also this is used. So what happens is, there is no water present, and because of the reflection of the sky and all these atmosphere layers, it appears as if water is present on the ground. And when you go towards it, when you go near it, you will find no water source available, nothing is present. So this is one of the best examples. Or if you are on highways and the temperature is very hot and humid, and on the roads at a certain distance, you can find out the mirage formation. Means you can see the image of tree or slight images of something which are not present. This is because of total internal reflection. The light ray which was supposed to be deviated now gets totally internally reflected. So reflection appears. The way we are able to see a normal reflection, this appears as a reflection. That is one of the applications. Second is brilliance of diamond. Brilliance of diamond means, let's say you have a diamond is present, a diamond stone is there. What happens when the light ray enters? That is true reflection, Zainab. That is a true reflection. Water acts as a very smooth, shiny surface, and it actually, the light rays enter the water surface, it gets reflected, and normal laws of reflections are followed over there. The fact when there is no object or there is no medium to be reflected, and then you see, like on a road is not a smooth shiny surface where we expect an image to be there. That is because of TIR. The normal reflection that we see in water is just a normal reflection we see in a plane mirror. So that exactly has the same property.
Yes.
In case of diamond, what happens when the light enters? It keeps on suffering total internal reflections. Multiple total internal reflections are present. Okay, so this gets totally internally reflected, then it gets totally internally reflected, then it gets like this, the light gets trapped and it keeps on moving, it keeps on moving. The light keeps on getting totally internally reflected. So brilliance of diamond basically means the shining of diamond. Okay. If you take a stone, a shiny stone like diamond, so and if you turn it a little slightly, or you turn your angle, you will be able to see complete shine, right? The diamond, that is what the property of diamond is exactly. So it is said to be that the light is as if it is trapped once, and that light is continuously moving in the diamond, which we are able to see, and which we say this is the brilliance of diamonds, means shining of the diamond. So refractive index is very high and the critical angle is very small, and the value of the critical angle is 27 degrees here in case of diamond. Yes, the cuts are made so that the total internal reflection occurs, so that this critical angle is achieved. That is correct. The cuts and all, they are made in the diamond so that this critical angle is achieved. Otherwise, it will be a regular stone, and this property can be exhibited in diamond only because of the high pressure and everything. Whenever it is made, the critical angle is kept in mind. Yes, so that's right. Okay, so light gets trapped. Then you have the concept of totally reflecting prisms. Totally reflecting prisms means you will have the object will pass through prism, an image will be created. Now this image will be a reflection of the object. Prism class we'll study in detail, so don't worry about prism. Prism देखेंगे हम लोग बाद में. अभी फिलहाल ये देखो, two values we'll see when the light ray is reflected by 90 degree and reflection by 180 degrees. So in all the cases, we'll take right angled prisms. Okay, the prisms that we are taking, these are right angled prisms. Okay, so let's say we have our object here. So how is it deviated? Now look, the light ray will fall on this surface, the other light ray will fall on the surface. Now this is made in such a manner that TIR occurs here. Okay, when TIR occurs, this will be reflected. See, here we'll have the normal. So this will be reflected because critical angle is exceeded. Similarly, here we'll get the normal. This will be reflected. This goes here. This went here. Now see, the image formation is this. So object, image, reflection by 90 degrees. This comes in the exam separately also. Okay, class, this one. And let's keep the object here. This is 90 degree. These are 45, 45 each. Okay. And here we are keeping our up, or I'll keep it here. Now what will happen? This will strike here. This will strike here. Okay. Here we'll have our normal. This will be reflected here. Here we'll have our normal. This will be reflected here. Here again we'll have our normal. So this will be reflected here. This will be reflected here. So what will happen? The image formation. So see, object, image, angle, 180 degrees. Okay. Then we have optical fiber that are present. Okay. Now, in case of optical fibers, class C, in optical fibers, oh, we did one question which Aisha was mentioning. No, Jesslyn, which you were saying, no, the optical fibers, the one which we did. So, optical mouse, I think you all must have seen. Optical mouse, light is there and the optical mouse is present.
Yes, ma'am.
Red light is there, na? So
Yes, ma'am.
basically that wire that is known as the optical fiber. Okay, the wire that we use, that is the optical fiber which we use. So optical fiber uses this property, and that's why there is light also over there. So the light ray keeps on. Okay, so these are various examples and properties of applications. Please note it down. If you have any doubts in between, ask.
Done.
Class C, coming to the spherical refracting surfaces. Just a second. Turn off. Yes, class. Coming to the spherical refracting surfaces, see, spherical refracting surface, the way we have studied mirrors. What were mirrors? Mirrors are basically the part of the spherical surface that we take and we silver it. Okay, we silver it. In spherical refracting surfaces, we'll be taking just the surface as it is directly. And then we'll see how the reflection and refraction occur. See, reflection isn't possible because there is no plane surface in order to make it push back, right? So what we do here, we take the spherical refracting surface as it is, means we just take a portion of the glass. We just break the portion of the glass over here. All right. So let's say we have taken. See, let's say this is a glass surface that we have. Now we have taken this portion. Here we are neither silvering this side or that side. That is what we are taking. Okay. This is what we have it. So what we do here, if we are taking one portion, now how to determine whether it's a convex surface or it's a concave surface? You see where the denser medium is present or the rarer medium is present. All right, rarer and denser, this will determine. See, how will you identify where the light is traveling from where to where? Okay, so see, in this, lot of cases can be made. When you take this, a lot of cases can be made over here because denser medium is also present, the rarer medium is also present. And one more possibility is in the concave part. See, we'll have four possibilities if we see in this manner. Concave surface is present, concave surfaces, convex and concave surfaces are present. Let's say we have a convex surface. So denser medium here, rarer medium here. One case, rarer, denser. Second case. Then similarly, we take the concave portion. Just take the concave part. Denser outside, rarer inside. Similarly, take this rarer outside, denser inside. All right. So this is what you have to consider in this spherical refracting surfaces. Basically, see, formula will be the same. You will have to identify what all, which case is it. Formula has a very slight change, class. All right. So what all things we have? The refractive index of the denser medium, refractive index of the rarer medium. We'll have the image distance, we'll have the object distance, and we'll have the radius of curvature. And basically, we'll try to establish a relationship between here. Okay, between all these, we'll try to establish a relation. Is that clear what I'm saying? What all four cases are there? I'll just show you. Look, refraction from rarer to denser. Now, what all possibilities are there? This means that your object is present in the rarer case. Okay, and the image is there in the denser one. Okay, so here you have two cases, convex and concave are possible. In convex, how to identify if it is given in the reverse manner? Means you will have the final image and you'll have to calculate from where is it going. So convex will be real and virtual which is present. Concave, you will have real and virtual. Okay, for the rarer to denser. mostly class in this you will actually get real images formed only because there is no reflection, and there is, if there are successive mirrors present or lens present in between your calculations, then you can get a virtual image as well. Okay, for the virtual image this is how you will get. So from rarer to denser, you will have the light ray, means the object is in the rarer part, image is in the denser part. All right, similarly from denser to rarer you will calculate. So denser you will have the object put, rarer you will have the image put. All right, so convex is there, concave is there, convex portion is present, and see, that's what I'm saying. 4 cases are possible in this manner only. But majorly, you will have to remember 2 formula for this and this. Okay, so see, derivation is also there. Do one thing, copy this part, then let's start with the derivation. Okay, first write down this introduction part.
Ma'am, we didn't take class for the transformer part from alternating current.
Okay, yes, Aisha, your class is pending. No? I forgot this.
Me and Halwa also. The electromagnetic also.
Yes, a little portion of electromagnetic was left and AC is left. AC, no. EM waves, you have attended completely?
No, not the beginning part.
The EM wave is also left. Alternating current में से transformers बचा है ना?
Yes, ma'am. We last thing it was average power.
Okay, so transformers is left and EM waves. So that requires just one class. When you people are free, Aisha, Marwa, when do
You said
you?
you would take last Sunday.
Sunday.
Any day is fine though. For me.
Any day is fine. Let me just inform the team for this. They'll just check up your schedule. Is your online class over, Aisha? Or all the online classes which you were having from the school, are they over?
We finished most I like till this week maybe half week maybe like
So they
yeah
are
this
still
coming week we'll
ongoing.
finish.
The classes are still ongoing.
Yeah.
Okay. So are you able to then manage with both of these because your
I
chemistry
wasn't
class
able
will
to
be.
join them like because I had Learnivio, so I joined this instead.
Okay, so timings are clashing. No? Still the timings are clashing. Your chemistry class is from 9:30. Like, what is the timing of your chemistry class?
8:30 also 8:30 same on Wednesdays and Thursday.
8:30 IST.
And no here UAE time.
UAE timing. So 10 o'clock it would be here. 1.5 hours cap hai na? So 10 o'clock. No? Okay, so
Oh,
that will
9:30 IST 9:30.
9:30 IST. You have the chemistry
Yeah,
class.
yeah.
Okay. Okay. कब तक है ऐसे classes?
मैम नेक्स्ट वीक तक खत्म हो जाएंगे.
Okay. Still date?
We have less portion left. Like we'll finish it maybe this week.
Okay then. So will you be able to manage then, Naisha?
Mm. I'm not joining those classes like because the timings are almost like same time.
So will your teachers not say anything?
I'll follow this because we finished these chapters, the one they're teaching. Yeah, we
Okay.
finished atoms only. We finished all those chapters. We're doing
So what are
alternating
they then?
current right now.
Why are they taking online classes if the syllabus is stable?
Because you have boards like coming November, the beginning month, pre-boards.
Okay, so you have your offline classes going normally, and then these are the extra classes that are put.
Yeah, so we can finish the portions because we'll have pre-boards.
I'll take your class then. See, 1 hour is probably needed. 1 hour is enough. Marva is also there for this. I'll just let you know. Okay. It's Tuesday today, Thursday. It's Wednesday, no? So you have your okay. You don't have the Tuesday Thursday's class. That time you have the chemistry's class. Then we'll be left with Friday and Sunday. Sunday I'll try. Okay, Aisha. Marwa, are you free Sunday?
Yes, ma'am.
Sunday in the evening around 8 o'clock IST, we can have a class. 8 p.m. IST, are you there?
Yes.
Then let's have the class time. Okay. Please copy this.
Ma'am, Sunday we usually have biology classes.
Sunday you have bio classes in the evening.
In the evening, here, Gulf time, it is 7 o'clock.
Okay. All right. Let me just take your schedule first. Please wait. No, Aisha, we started at 10 today, no? Is it done? Till here, have you all written?
Yes.
Yes, ma'am.
Okay, see class, now coming from the refraction, one derivation I'll be discussing, the other derivation you'll be able to manage. Okay, denser to rarer. Same concept is there. I'll just tell you how you have to do. Because it's a little lengthy derivation, so do that second part by yourself only. Here what happens is, this is the refracting surface, this one. Okay, here our object is present. Now what happens is, the ray of light goes from the object towards the refracting surface. All right. I have told you multiple times that what you do whenever you have the normal to be dropped on the surface, you join the line with the center of curvature. If you join the normal with the center of curvature, any line you join it with the center of curvature, you will get the perpendicular to the plane. So this will also give us the perpendicular to the plane. So from the object, the ray of light is coming, and this is the angle of incidence that is present. Okay. Now, what happens here? The ray of light gets refracted as per the change in the medium. This is one side, this is another side. So you have N1 present here, you have N2. Means N1 and N2 are different refractive indices present. What we do here, see, between the incident ray, this is our incident ray, this is the normal. Between the incident ray and the normal, we take the angle of incidence. So this becomes the angle of incidence. And between the refracted ray and the normal, we take the angle of refraction. So this becomes the angle of refraction, that is R. That's why I has been written, R has been written, N1 is there, N2 is there. This is O. Now see here, images has been formed, center of curvature is on this side. Now what we do, we take up three angles just for the calculations part. Okay, this isn't related to any significant value of the ray optics. Nothing. Angle of incidence पता होना चाहिए, angle of reflection पता होना चाहिए. In fact, here this is refraction, not reflection. So what you do here, you take the angle, one of the angles is alpha, you take the other angle as beta, you take one angle as gamma. These namings are done by NCRT, so that's why I've taken them as it is. Otherwise, you can take up different values of it also. Now see, here what we do, from the pole only, we'll be moving from the pole. Still from the pole, we'll move either towards the left or towards the right. So from the pole, move towards the object. Okay, then move towards the image, move towards the radius of curvature and all. So see, from the pole to the object, this separation is the object distance, that is u. Then from the pole to the center of curvature, this becomes the radius of curvature, that is r. Then from the pole to the image, this becomes the image distance, that is v. Okay, so these are the landmarks that we have. We do one more thing. See, this isn't a triangle. This is an arc. This isn't a triangle. So what we do, we drop a perpendicular here. Now see, these points P and N, they are so close to each other. Okay, they are so close to each other that P and N are almost negligible. So you solve it using N. You can replace it with the pole because N is not any reference point, right? N is not a reference point. So for N, you will have to replace it with P. Okay, now let's see. Let's apply Snell's law over here. See, yes, this somebody else will apply. Yes, Zainab, can you try Snell's law? How do we write the Snell's law, Zainab?
Sin I by sin R is equal to N2.
Okay, cross multiplication में बताओ. In cross multiplication, what will it be?
N2 by N1.
Okay, N2 by N1 is equal to what?
Sin I by sin R.
Sin I by sin R. So see, in cross multiplication means these two, like this, N1 multiplied to sin I. Okay, this is what I was asking because right now it's fine that this is N2, this is N1. What if I interchange N1 and N2 and the meaning changes? Because N1 and N2 are not fixed. That's why I try to write it in this manner. You're absolutely right. See, but try to write in this, like N1 is it, then take the sine of the same angle. Sin I is equal to then N2 into sin R. Now what we do, we take a small angle approximation. Small angle approximation means the aperture is very small. So these angles of incidence, angle of refraction, these are not very huge. So what we do, we approximate their values, like sine theta will almost be equal to theta. So you can say N1 into I is equal to N2 into R. Now we'll have to find out the values of I and R, right? Now look, Exterior angle property, if you can recall. Aisha, can you recall exterior triangle property? Exterior angle property you must have done. I, alpha, R. Sorry, I, alpha, and gamma. Can you connect these three using angle from exterior angle property?
Sum of it is equal to angle I.
Let me just share the screen. Class, am I audible to all? First thing, angle I we've got. Now we have to find out R. Okay. Yes, Zobita, can you apply exterior angle property for R, gamma, and beta? The way we have written alpha plus gamma is equal to I. Yes.
Beta plus gamma.
Beta plus gamma. No, see, if this is your triangle, no, this is the exterior angle. So beta plus R is equal to gamma. They'll be equal. No. Why will they be equal? Gamma is equal to beta plus R. Exactly. Right. See, gamma is equal to R plus beta. Some of these. So gamma is equal to R plus beta. So from here, what is R? Gamma minus beta. Now let's put the values here. N1 will be, this is N1 into alpha plus gamma is equal to N2 into gamma minus beta.
Ma'am, isn't it triangle ACI?
A,
I mistook it.
M, C, I. Okay, and यहाँ पे M, C, O. Here. All right, so these are the values of the refractive index that have been written. Now, alpha, beta, gamma, all these things have to be written. Okay, so what we do, we take up the triangles. Like for tan alpha, see this triangle we take OMN. Tan alpha is equal to MN divided by ON. Okay, so that has been written. Then tan beta, we take again MN divided by NI. Perpendicular by base, that's what I'm doing. Perpendicular by base for beta. Then similarly for gamma, perpendicular by base. For alpha, perpendicular upon base. In all of it, Mn is common. Now let's put the value here. N1 into, one more thing, since these are small angle approximations, tan theta will also be almost equal to theta. Now alpha is first, so we'll write Mn by On plus alpha plus gamma plus gamma plus Mn divided by Nc is equal to N2. That is gamma minus beta. Gamma is Mn by Nc minus beta is Mn by Ni. See, Mn will be cancelled from all. Now we are left with these On, Nc. Basically, we have N1 is equal to 1 by On plus 1 by nc is equal to n2 into 1 by nc minus 1 by ni. Now let's open up the brackets and put the values. What is on? See, on is almost equal to, look class, on is almost equal to op. Our purpose was to take this. Op is u. Okay. Similarly, if we take this cn is basically cp, that is radius of curvature. Similarly, in is equal to ip, that is the v. So all these values we'll be putting with the proper sign conventions. U will be in front of it, so mine is vn plus r. Now see, this will be n1 by minus u plus n1 by r is equal to n2 by r minus n2 by v. These values I've put in here. Are you getting? N and p are very close to each other. I'll write it here. N and p are very close to each other. That's why we have replaced it. Okay, now let's bring the terms on the opposite side. N1 by minus u, let's bring it here, plus N2 by v. This is equal to N2 by r minus N1 by r. Take r as a common denominator, N1 by minus u plus N2 by v is equal to N2 minus N1 divided by r. This is the whole formula. Okay. Write down this derivation. Then for the next one, I'll tell you that you will do from your end. Please write it from here. Should I scroll down?
No, ma'am.
Done, ma'am. Okay then. If completed till here, then in the next class we will continue. Okay. All right. Thank you.
Thank you, ma'am. Bye.